This is Lab 3 Circuits for Physics 2212. The purpose of this lab was to predict the behavior of circuits containing resistors in parallel and in series to examine characteristics of ohmic resistors and capacitors. Multimeters were used to measure conventional current and potential difference. As a preview of the results, the circuit with two resistors had a current of 20.3 milliamps, and the experimental and expected currents were similar. We found the RC of the second circuit that we built to be 5.919 seconds, and we found that the greater the resistance in an RC circuit, the longer it takes for the capacitor to charge. Important theory for this experiment is Kirchhoff's loop rule, which states that the sum of potential differences around any closed loop in a circuit must be equal to 0. Kirchhoff's node rule, which means that the total current entering a node in a circuit is equal to the total current leaving a circuit, or that node in a circuit. And then Ohm's law, which says that current through a conductor is directly proportional to voltage and inversely proportional to resistance. And then the lab RC equation given to us to calculate R, which is seen right here. For our experimental procedure, we constructed this circuit seen here, and this is what it looked like when it was built. The expected values of I1 and I2 seen in this diagram better, not as clearly seen here, it should be here and here, were 20 milliamps. The actual measured values of both were 20.3 milliamps, and when the ammeter was reversed, the value was negative 20.3 milliamps. And when one ammeter was turned into a voltmeter, we got the voltmeter showed 3.12 volts and 0 amps. Continuing with our experiment, we measured the voltage across the resistors. For R1, we found 0.95 volts, R2, 2.03 volts, the ammeter, 0.1 volt, and the sum voltage of all three of these was 3.08 volts. The sum is close to 3.112, the voltage of the battery, and that remaining little bit comes from the wire. So when remeasured, the 100 ohm resistor had a current of 20.3 milliamps. And then when a voltmeter was swapped with an ammeter, we found a current of 57 milliamps and 0.5 volts. And here you can see a graph of the resistance, including our resistors, our ammeter, and both of our batteries. We then used Ohm's law to calculate the resistance for each of the resistors, ammeter, and the wire, which came from that remaining portion. We found R1 to be 46.80 ohms, R2 100.1 ohms, the wire to be 2.46 ohms, and the ammeter to be 4.92 ohms. For the second part of this experiment, we constructed this RC current circuit to the left, which is seen in real life right here. And we observe the behavior of a light bulb. So for both charging and discharging of this capacitor, the light started as very bright and slowly dimmed until there was no light left. The charge time we measured was 22 seconds, and the discharge time was 13 seconds. And we calculated RC with the formula given to us earlier in the theory section, and that was 5.919 seconds. For this lab, some assumptions that we made were all of the rules needed for Ohm's law and Kirchhoff's rules to hold true, and sources of error could have been loss of charge to the environment or errors in our calculations. For our what if question, we were asked, what if you charged a capacitor with no resistor in the circuit? How quickly would our ideal model predict the capacitor to reach full charge? Would this prediction happen in real life? And then we're asked to explain. And then we used an ammeter to measure how long it takes to charge a capacitor connected directly to the battery, and then discuss why this is different from the predicted time. In an ideal model, a capacitor connected directly to a battery with no resistor would charge instantly because there's no resistance to that current. However, in reality, there's internal resistance, some resistance built into each battery, so it takes some time to charge a capacitor, and we observed that when using an ammeter, it showed a longer charging time because of that resistance than you would expect from connecting directly to a battery.